Hello, welcome back. We are going to do the problem number one now. So let's take a look at problem one. This is homework one and problem one. So let me do this. Homework one, problem one. Okay, so we are going to look at some circuit. I would first like to give an example similar to the homework problem. This is a little bit more simpler one, so we are going to look at an RLC circuit now. So as you recall, resistance, inductance, and capacitor. So here we have a circuit. Let's call it a series circuit. So here I got a minus, plus, let me call this V of t, and this, here you have a resistor R. So here's that resistor. Here you got an inductor L, and here is your capacitor. Well, try to solve this problem in a time domain, and yes, this can get a little complicated if you try to do this problem in a time domain. So we will do this in the frequency domain. Recall in the table in the previous discussion or lecture or whatever you want to call it, we said that the impedance in the S domain, when it's a capacitor, we can express as 1 over Cs. And then this guy is basically S times L. And this can go back to what you have learned before. Remember, back in your AC circuits, you were told that the capacitive reactance is 1 over 2 pi Fc, where this is actually omega. In reality, we write J omega C. So the reactance in S domain now becomes X of SC. Okay, so much for that. Now we got a series circuit, so we are going to write an equation in the S domain. Now remember this V of t, instead of writing V of t, let me erase this and write it totally in S domain now for you. So this is going to be V of S. And we are going to call this voltage across the capacitor as Vc of S. So the goal right now is to find the transfer function. So as you recall, the transfer function is always the input divided by the output. So in this case, you can see we are taking the voltage across this capacitor, if you will, right there, and this is your input. So the transfer function essentially is going to be nothing, but here is your system, let's say. This system itself is the system that we're talking about. And you have an input going in as V of S, and the output coming out as Vc of S. And our goal is to essentially find out what this transfer function is going to be. Vc of S over V of S. Well, let's see what happens. So series circuit, we all know there's a current going through it also, and we're going to write this current in the S domain too, I of S. No need to write it in the time domain because that can make a little bit complicated issue, right? So here we go. The input voltage, as you know, is a series circuit. V of S must be equal to drop across this guy, drop across this guy, plus the drop across this guy. Well, let's see. So that will be R times the current, Ohm's law. Essentially, you're applying nothing but Ohm's law in here. So this is I of S times the SL, right? Plus I of S over CS. Doesn't look that bad, does it? So what can we do from this? Well, we can find the current in this circuit, right? As you recall, in the series circuit, the current is same. So a little bit of math here, if you will. V of S, we factor out I of S. And if you do that, that will become an equation like this. RSL plus 1 over, this is C times S, same thing, right? C times S, here you go. So here we can find the current. So IFS is equal to V of S divided by R plus SL plus 1 over CS. Here we go. Now we got the current, right? So let me move this a little bit up so that we'll have more space to write here and go in kind of a sequence here. So we know we are trying to find the output, right? So the output is across that capacitor. So VCFS, as you recall, that is going to be the current times the impedance, which in our case for the capacitor is 1 C times S. Remember that, right? Because voltage divided by the current gives you the impedance, and this guy is indeed impedance. Let me call that impedance. Impedance. Well, we're almost there now, right? So now all we got to do is plug this guy into this one. So we're going to plug this guy here. So VC of S is essentially going to be a I'm going to put this here, CFS, and we know IFS, so let's put this guy over here. VFS is equal to R SL plus 1 over CS. Doesn't look that bad, does it? So we are going to try to simplify this a little bit more. So to make our life a little bit better, let's simplify this. So hopefully you're with me so far. If not, you can always find me whenever you want. Text me or send me a Skype message if I'm up and around. Virtual office hours are there. We can always meet at 2 o'clock, or we can meet anytime you wish if we both are available, right? Or whoever is trying to call. But anyways, let's take a look at this guy now. So VCFS, a little bit of algebra going on in here. CFS is equal to V of S, and if I do this, this will become S squared LC, pretty neat, and this guy will become RCS plus 1, and of course this CS can come here. Hopefully we all remember how to do our math, right? So this guy and this guy is going to cancel out. So, my friends, CFS is simply now going to be equal to V of S. Now, if I want to just represent this and take out this guy, L sub C, I can divide throughout by L sub C, right? So here we go. This is going to be S squared plus, in other words, factor out LC, if you will. So that will become what? So that will become R sub C divided by LC, S plus 1 over LC. Well, this C and C will cancel out. Right, so what do we have here now? Pretty interesting stuff going on. So here, my friends, this is what we get now. So if this video gets a little bit longer, please pardon me for that. So we can say V of S, and we can write this guy as 1 over LC divided by S squared plus R over L S plus 1 over LC. Here you go. This is your transfer function. So if you want to represent this in a block diagramic way, instead of writing it there, let me draw the system here. This is your system, and we can write this guy as 1 over LC divided by S squared plus R over S plus 1 over LC. And here you go. Here's the input, VC of S, of VFS. This is going to help you to solve problem number 2, homework 1. So I'll see you in the next video shortly, and I'll try to give you one more example so that you can do problem 1, problem 1, not problem 2. Let's change this. Problem 1, homework 1. We already did problem 2. Problem 1, homework 1. Okay? So I'll see you shortly here in the next video. Okay? Thank you.